Let's start with a brief history of imaging. As you know, all this dates back to the pinhole camera, which is a concept that Chinese philosophers were talking about back in 500 BC. And then somewhere around 1000 AD, Arabian philosophers and scientists described the pinhole camera and its properties in great amount of detail. It's only in the 16th century that it came to the West and became very popular among artists. So here you see what's going on. This is a sketch by Gemma Frisius. You have a tiny pinhole in this wall here, and that projects the three-dimensional scene onto the second wall to create a two-dimensional image. And your artist can simply walk up to this wall and make a beautiful, accurate representation sketch of the two-dimensional image. So the artist was very much a part of the loop. And it was realized that the pinhole camera is very powerful in terms of the sharpness of the images that it's able to create, but it was also realized that it simply did not capture enough light. The images were really dim. And so almost immediately, in the subsequent couple of decades, the pinhole camera was enhanced with the addition of a lens. So this image that I'm showing you, this sketch, is really from the 17th century. But what happened was that you were able to create images that were much brighter, and with time, the effort was focused on making this process much more comfortable for the artist. So here you see that you have a lens, and the lens creates an image, which is, of course, a vertical image, but this image is being folded by the use of a mirror, a 45-degree mirror right here, so that the final image is created on a horizontal plane, and the artist can very comfortably sit down and make a sketch of the scene. So the artist this was all being done to serve the artist, was the most important part of the loop, so to speak. So from that perspective, you can imagine, and many have argued, that perhaps the most important invention in the history of photography is the invention of film. So this is a photograph taken with a daguerreotype camera, which was invented by Daguerre in the 1830s. This photograph was taken in 1837. And just think about this for a second. For the first time, you could actually memorialize, document, or record a moment without an artist, and instantly you simply press a button, and whatever it is that you see in front of you, you're able to record that on a physical layer. Just an amazing point in time in terms of human culture, human expression. So how did this work? Well, film essentially typically has a layer of silver halide on it, and when you expose any point on the film, the silver halide gets converted to metallic silver, and the amount of conversion depends on the exposure of that particular point. So you expose a film, and then you develop the film using a chemical process, and you finally get a photograph that looks something like this. So you were able to get very nice, very clear, high resolution, black and white photos, but taking this to color became really hard. It turns out that actually capturing an entire photograph with full color is an extremely challenging process. It required some real inventions in chemistry. But after a few decades, almost 30 to 40 years, we began to see color photography in its full glory. So here you see one of the first color photographs captured in 1887. And the way this works is that you still use a silver halide layer, but then you have another layer sitting next to it, which is called a dye coupler. And this dye coupler has pigments in it, and there's some very interesting chemistry that happens when you expose these two layers to light. So then, a few decades later, you began to see consumer film cameras. This is in the 1920s or so. Here you see the Ernemann camera and an advertisement for it. It says, what you can see, you can photograph. Just think about that for a second. You're telling people, the masses, that whatever it is that you see with your eyes, you can actually photograph, you can memorialize it. So just an an amazing time when humans were able to express themselves visually and communicate in a way that was never possible in human culture before. So this is why I think very often the invention of film was considered to be the most important invention in the history of photography. But I'll argue that the most important invention was the invention of the silicon image detector. Just think about this for a second. This thing, this little chip here, does exactly what film can do, except you don't need to develop it. You don't need to get another chip every time you take a picture. The same chip can capture an infinite number of images for you. That's just an amazing concept, just opening up a new chapter in terms of visual communication and expression. And it turns out it took about 20 years, 2 decades or so, for this technology, very sophisticated technology, as we'll see in this lecture, to actually mature. And when that happened, we began to see the explosion of digital cameras in the marketplace. These are some of the first cameras, digital cameras, that actually came out. You can see on the top left corner here, you see the Nikon Coolpix. These cameras would usually capture a 640 by 480 image, or perhaps a 1 megapixel image. That was considered to be amazing resolution back then. And they were very power hungry. If you went out and captured a couple of dozens of images, you'd run out of battery power. You would come back and you'd have to replace the battery and then go back out again. But anyway, the demand for this technology was so high that industry was driven to innovate very quickly and make advances on every dimension of imaging. And somewhere around the end of the 20th century, around 2000, we began to see smartphones with cameras in them for the first time. That was a huge achievement because you had to miniaturize these devices substantially to get there. And you had to make significant advances in terms of performance as well. Then somewhere around 2007, we began to see iPhone cameras, camera phones. And you can see here, this is iPhone 1 with a tiny little camera here. And that was a beginning of a new revolution in imaging, I would say. On one hand, it really made a lot of things possible with respect to computer vision and artificial intelligence, and we're actually living in that moment right now. And at the same time, there was a second revolution that was happening, which is the explosion of visual communication. It turns out that the younger generation prefers to communicate using photos and videos over words, written words, and voice. And so we began to see platforms like Snapchat and Instagram, where a billion or billions of users communicate visually on a daily basis today. So that's the age that we live in at the moment. Now, this brief history that I've given you, I'd like to sort of punctuate it with 2 examples, one in the beginning and one towards the end. So let's start out with this camera right here. And this is called the Kodak Brownie. It was a gift given to me by one of my students. And this is to show you how long we've come in 100 years. This was put out in the market in the year 1900. It was called the Kodak Brownie 1, model number 1. And guess how much it sold for? Well, it turns out it was exactly $1. So $1 back then is roughly $30 in today's money, but it was $1. And the next year, they came up with a refined version, which is Brownie 2, which sold for $2. Think about that. Interesting. So let's take a look at this. So here you have in the front, if you open it up, I hope you can see this, you have right here your lens sitting in the back, and you have a little shutter which is able to spin around and block the lens and open it at times. Here you can see that it's fully open, the lens. And unlike the aperture that you see in cameras these days that has a diaphragm, in this case you don't really have a diaphragm, you actually have a little slider here which allows you to change the diameter. You have multiple apertures and you can simply choose the one that you want right there. Then you have the shutter that exposes the film to the outside world for a certain amount of time. And right up here you see a viewfinder. Remember back in 1900, there was no display technology, so you had to look through this viewfinder to see what the camera was seeing before you take your picture. And then you have here your film holder. So you would take this out and you would load up a film there. The film would look like something like this, a roll of film, and wrap it around and then put it back in there. And then once you've shot the entire roll, remember you can't really develop one photograph, but an entire roll of photographs. And then you would send it to, say, a company like Kodak, which made this camera, and have it developed, and they would send it back to you by mail. So it would probably be several weeks, a month or so between the time you actually take your picture and the time you get to see your picture. Clearly doesn't lend itself to computer vision, but remarkable all the same. Now, let me say a few things about the technology that was being used here. The lenses in here were made of surfaces that were spherical because that was the only technology that was available back then. We knew how to grind spherical surfaces, but not surfaces that were aspherical. In terms of focusing, this was a fixed focused camera. There was no way to adjust the focus. And in terms of knowing what you're shooting, the viewfinder was your only way to do that. You couldn't really see a visual representation of the image. And like I said, your aperture was a little bit primitive, very simple slider. And then the film, of course, was a roll of film, right, which had to be developed. Now, where are we today? Well, quite remarkable. 100 or so years later, this is your complete camera today. I don't know if you can see that. It may be too small for you to see, which by itself is probably very impressive. But this little tiny thing that you see here is the camera module that goes into your phone. And this starts off in the front with a little lens. These lenses no longer need to be spherical in shape. They can be made of plastic and molded to be aspherical, which is very powerful because with a smaller number of lenses, you can make very sharp images with very high quality images. And then the lens itself sits on a voice coil so that if you want to change the focusing, you can simply adjust the focusing. You can send a voltage to the voice coil and very finely controlled at a micron level the position of the lens with respect to the image plane. And then, of course, there is the image sensor itself, which we talked about. Just remarkable achievement and huge advances, very sophisticated fabrication technology that can produce for you 20, 30 megapixels today, even in a phone if you wanted. And then sitting behind that image plane is on the same chip, is enough computational horsepower to do early processing of the image and enhance the image and even compress it, images and videos. It's just amazing what's happened. I want to give you a little bit of a glimpse as to where this is going to go. In the coming decades, this is going to get even smaller, but even more powerful in the sense that on a single chip, rather than having a separate lens on top of it, we're going to be able to grow the optics on the wafer itself. So it's called optics on wafer. And then there's a layer that senses the image, and underneath that layer, we're going to have what's called 3D electronics, where you can have a lot of computational horsepower to actually embed an entire computer vision system. So while this is a camera, a sophisticated camera today, something even smaller than it is going to be a complete computer vision system in the future. That's been the journey, 100 years. And it's taken not just miniaturization, but tremendous advances along each one of the dimensions that is critical to imaging: optics and sensing, as well as computations.